Hello, ladies and gentlemen. Today we will be doing pre-calc lesson 8. We will be talking about statements of similarity, proportional segments, angle bisectors, and side ratios. So let's get started with our statements of similarity. Okay. In our statements of similarity, it is very important to remember that order matters. We always do things in the same order, no matter what we are doing. For example, if I had these two triangles, both of them right triangles, A, B, C, and I said this angle was similar, and then I had this triangle here with, this is our similar angle, E, D, F, you have to notice the orientation of each triangle, where the right angle is, where the similar angle is. So in this, I would have to say that triangle ABC is similar, ABC is similar to triangle DEF. I cannot say triangle ABC is similar to triangle DFE. No, we cannot do that. Because that implies, if I go ABC, that implies that angle B would be similar to angle F if I go DFE. And that is not what we are saying. Very, very, very important that you have it in the correct order. So let's do an example. This is example 8.1 on page 61 in your book. And we have this triangle here, triangle ABC. This is a right angle, okay? And I have segment BD, so I'm going to draw this down here and make a right angle. Since there is a right angle there, this line is perpendicular to the base, which means that segment BD is the altitude, or our height. Remember, the height is always perpendicular to the base. And I want to show that AD over AB is the same as AB over AC. Okay? Now, what we want to do in that is we need to look at the different triangles that I have. One of my triangles is ABC, and another triangle I have is ADB. Okay, so I'm going to redraw my triangles. That's B, A, and C. And if I redraw that little triangle, D, A, and B. Okay? Now what we notice is these angles are the same. They're both A, right? This angle is similar to itself. And since they are both right triangles, I can say that triangle ABC is similar to triangle ADB. Since that is true, I can write two ratios talking about the similarity. So I can say that AD is similar to AB because they are both legs of my triangle. I can also say that DB is similar to BC, and I can say that AC is similar to AB. Okay? Now, I want to look at these two because that's what they want us to do. Now I can say that AD over AB, right, equals, because they are similar triangles, and I can talk about ratios, I cannot say, however, that it equals AC over AB, because then I would be going in the wrong order, right? I started with, let's call this triangle 1, let's call this triangle 2. I went triangle 1 to triangle 2. So over here, I have to keep it the same, triangle 1 to triangle 2, which means I do AB over AC. That's all that it is. Statements of similarity. Okay? Now, let's talk about proportional. I'm going to write it as proportional segments, or prop seg if you write like I do. Okay? We know that parallel lines cut proportional segments from any two intersecting transversals. Okay? Remember, the double line here means parallel. So what does that mean? If I have two parallel lines, or more, but I'm going to start with two. Right? If I have two parallel lines and I have two different transversals, it cuts them into proportional segments. My proportional segments are these different segments here, 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 and here. Okay? So, let's just jump right into an example. This is example 8.2 in page 63. Okay, in this case, I have three parallel lines cut by two transversals, and it creates a portion x plus 1, 13, x plus 4, and 19. Now, remember, these arrows, should have drawn it up there, these arrows mean that they are parallel. Okay, and I want to find x, go figure. So what I know is I know that I have proportional segments. So I'm going to write it here as x plus 1 is proportional to 13, and x plus 4 is to 19. Now we have a case of cross multiplication. So I have 19 times x plus 1 equals 13 times x plus 4. I distribute, so I'll have 19x plus 19 is 13x plus 52. I want to bring my 13x over here and my 19 over here, giving me that 6x is 33. So x is 11 over 2. Remember, you have to be consistent with the order of your segments. Okay? This also can work if we have different triangles, which I'll show you that. We have to redo our next portion. Remember, if you have any questions, you need to write it down so we can talk about it in class tomorrow. Let's move on and talk about angle bisectors and side ratios. Okay? Angle bisectors and side ratios. If we have a line segment that bisects an angle of a triangle, it also bisects the sides. So let me write that out. If a line segment bisects an angle of a triangle, it also divides the opposite side into segments proportional to the other two sides. So what does that mean? If I have this triangle here, okay? This is my angle here. I'm going to bisect it. When we bisect an angle, it cuts the angle in half, meaning that those two portions are the same. And I now have these four little portions here. I'm going to say A, B, C, D. I can say that A is to B as C is to D, right? Which mathematically we would write it as A over B is C over D. Or, if I draw the same triangle, bisect my angle, and I have A, B, C, and D, I can say that A is to C as B is to D. So A over C is B over D. Again, it doesn't matter if you go across the triangle or down, as long as you keep it consistent. Whatever you do first, you have to do for the whole entire thing. Okay? So let's do an example. This is example 8.3 on page 64 if you're following along in your book. I have this triangle, ABC, and I'm going to bisect down to here to D. Now, when I bisect, that does not mean that there is necessarily a right angle here. We don't know if that's true or not, so don't draw a right angle. And we have this is 10, this is 15, x, and 12. Again, we want to find x. There's two different ways you can do it. I'll show you one way, and then I'll show you the other. We can say that 10 over 15 is the same as x over 12. Or the second way, we can say 10 over x is the same as 15 over 12. In both of these cases, we just can cross multiply. So we will have 10 times 12 is the same as 15 times x. Again, here we have 10 times 12 is the same as 15 times x. Same thing on either side. So 120 is 15x. So x is 120 divided by 15, which is 8. We get the same answer either way, whether I do this first option or the second option. Just keep it consistent. We're all about consistency, okay? Let's do another example. This is example 8.4 on the same page. If I have a triangle here, triangle A, B, C, and I bisect this angle, it doesn't matter which angle you bisect, it's always the same. It cuts that angle exactly into two, which is why we can have proportional segments. This is x, 6, 20, and 14. Okay? Again, there are two ways that we can do it, right? If it helps you, redraw your triangle in the upright position. Make this A, B, C. Bisect here to D, right? We know that AC is 20, AB is X, BD is 6, and DC is 14. It doesn't matter if it's looking on its side or if it's upright. Doesn't matter, okay? So I can then say, right? I could say one way is x over 6 is the same as 20 over 14. Or another way, I could say 6 over 14 is the same as x over 20, which we know this is the same thing as saying x over 20 equals 6 over 14. Doesn't matter which side of the equal side we are on. Equal sign. Now we cross multiply. 14x is 6 times 20, which we get 6 times 20 is 14x. We know that this statement and this statement are exactly the same because it doesn't matter which side of the equal sign we are on. Then we say 14x is 120, which is now the same for both equations. So x is 120 over 14, which we have to simplify. For the love, simplify all of your problems, which gives me that x is then 60 over 7. Notice how I'm boxing my answer at the bottom. We always box our answers, right? Right. And that's the end for today. We'll see you in class tomorrow.